I want to start off with a question. Do you remember what you had for lunch or dinner 2 weeks ago? The answer is probably not. And you might think, oh, why is my memory so bad? Or why is my brain not working the way I want it to work? Why don't I remember these facts about my life? But I'm here to tell you, your brain is actually working perfectly fine, and it's working the way that it's designed. So today I want to talk about loops and learning loops. So to do this, we should start with the brain, obviously, and behavior. So there's a lot of stuff that we know about the brain, your neurons, how they fire, and also behavior, how you react in different environments, and all these psychological experiments we've heard of before. However, how do we connect them together? Brain and behavior. How does brain function cause you to become who you are, or give you a personality? Just like how this really accurate picture of Einstein, this is Einstein's brain, and this is your brain. One fold in Einstein's brain given to your brain, you probably still would not be able to come up with E equals mc squared. So just because someone's brain is their brain doesn't make them exactly who they are. So this connection is a lot of stuff that we're researching right now, and we don't have a definite answer, and we probably won't for a really long time. However, we do know some things about neuroscience and brain and behavior. And one of those is that underneath the surface, many, many things operate as loops. Everything is a loop. And could I get a volunteer to show like a very simple sensory motor loop? Could you hold out your hand like palm up like this? Yeah, and then I'm gonna put the book here, and then try your best to keep your hand still when I take the book away. Notice how his hand raised up a little. Okay, let's try that again. 3, 2, 1. His hand still raised up a little bit, even though it was maybe like a little minute. And now try to take off the book on your own. Okay, and then his hand won't move anymore. But essentially what was happening here as a sensory motor loop is that his brain and his cerebellum was predicting the amount of weight on his hand. And when that weight was predicted incorrectly when I took off the book, his hand will compensate by raising. But when he takes off the book himself, he has already predicted that that weight will be gone. And so his loop will run perfectly fine, and he can keep his hand still and be able to control that. So one of the other loops that I want to introduce today is one of the learning loops, which combines attention, memory, and emotion. And hopefully after this talk, you can use this information to remember things better and also to learn better. So the first part is attention. So attention, what is attention? William James, the founding father of American psychology, once said, everyone knows what attention is. But do we actually know what attention is? Can you point to a place in your brain and say, oh, that is attention? How are we studying attention? Attention is actually a very abstract thing if you think about it very deeply. But to simply define it just for today, attention can be thought of as when you have all these resources in your brain and you're trying to allocate them to different things. For example, right now you're listening to me speak, so you're allocating a lot of attention to me and you're giving me resources. Another example could be for when you're in class and you're listening to a teacher talk. You're giving her all your attention. However, you open up your MacBook, you start texting your friends. Now you're engaged in a different conversation and your resources are split in half, called like multitasking, as we call it. And this will divide your attention on both ends and lower your attention span. What's surprising is sometimes you don't really have control over what you're attending to. Your environment can be giving your brain multiple different signals. For example, what color chairs I'm looking at right now, or what the slide is saying, and what I'm saying at the same time. And these things will make your brain process them and allocate resources to process these things without you wanting to. So surprisingly, if you're sitting behind someone who's even texting in class, your brain will naturally give attention to that person texting, even if you're not the one that's actually texting. And that's why I always say, if you're going to online shop during class or text during class, sit in the last row so you don't bring everyone down with you, because it does affect people's comprehension if you're just in their periphery doing that. And the second part of the loop is memory. And memory is one of my favorite concepts, and it's very, very interesting. And it's also one of the only topics where you can connect brain and behavior pretty well. And that's because you can study it on so many different levels. For example, you can study neurons, how they fire, plasticity of your memory, and also neural patterns and cognition. I can test you right now and ask you to remember things, and you can tell me how much you remember them. And so they basically impact every single thing that you do every single day, and they kind of create who you are. Why you remember your name, your family, your hometown, who your friends are. These things are all impacted by memory, and your habits and the way you walk. All these things are different types of memory. So memory, could I ask you guys if memory is localized or distributed? Who thinks that memory is localized? No one. Okay. Who thinks that memory is distributed? Okay, everyone. Okay, well the answer is actually both. So the answer to any good debate is both, but the precise way as to which it is both is the best answer. So memory is localized because it does depend on individual synapses within your brain firing, like that yellow thing if you're not sure what a synapse is. It's just like a space between neurons. And it also is distributed because every time you recall a memory, you're recalling the entire network. So think of it as like a lot of highways intersecting. You always drive every single day. Imagine if they change one single road. That might change your whole trajectory, and you might have to take a whole different route just to get to the same place. So there's an individualized, localized change, but that causes an effect in your whole distributed network. So that's how memory can be localized and distributed. For example, right now I can ask you to remember the number 88.9. In 5 minutes, if I ask you what number did I tell you, and you tell me 88.9, many synapses may have changed in that time locally, but when you tell me 88.9, you are reigniting that whole network of your brain. So things like that is called like declarative memory. And a lot of research has shown that this type of plasticity inside your brain is mostly attributed to a structure called the hippocampus. And thus memory is part of everything and how your brain learns. And let's talk about memory consolidation. So how do you form memories, right? How are you remembering things, especially declarative memories? So the hippocampus is this small, like, snail-like structure at the very bottom, and then the cortex is like, you can think of it as like the outer part of your brain. And so when you form a new memory, it's not very strong. You can think of like things that you might have had a fleeting thought and you never thought back to, you never retrieved that memory again. You've probably forgotten it long by now. And so that's your new memory. It's very dependent on the hippocampus. And all the red lines, you need to go through the hippocampus to be forming this memory. However, over many months and years, if you keep retrieving this memory trace, and if you keep thinking about this for a long time, it's going to go to your cortex and be fully consolidated. And it's no longer as dependent on your hippocampus, making the memory more stable. And this is also why cramming doesn't really help, because you don't have that much time for the memory to consolidate until you might take the test. After a week or two, you're going to forget everything you just learned because you never went back to think about that memory, and it was very fragile, so you're going to lose it. And consolidation also happens a lot over sleep, which is why we should all sleep more. And how did we figure out this is how memory consolidation works? Well, there's a lot of interesting case studies, but one of them is patient EP. He had hippocampal damage in his middle years, but when we bring him back to his old neighborhood, his childhood neighborhood, he was able to remember it very well. And maybe like navigate his high school well, or like navigate where his old house was, because this was many years before his hippocampal damage. So all his memories have been consolidated in his cortex by now. And he also knew his name, his personality never changed, anything like that. However, EP cannot remember anything from his new neighborhood. So for example, if you've been living in Camas for 5 years, but you had hippocampal damage before you moved here, you will not know how to navigate Camas. You might not even know that you live in Camas. You cannot form any more new declarative memories because your hippocampus is no longer there as an anchor. And so your memories cannot be consolidated. You only have like very short-term memory, but you cannot remember things for a long time. And so this is why those like action movies like Born Identity, where someone washes up on shore and they forget everything about who they are, that's pretty scientifically inaccurate because your memory is fully consolidated. Your identity is a very strong neural network, and it won't just be like washed away by a little trauma. Usually amnesia is more like time differentiated instead of you forget everything about who you are. It's not very likely. So unfortunately, the Born Identity probably did not happen. As you probably have noticed by now in like movies like Inside Out, a lot of your main memories are very emotion-filled. You might not remember what you ate for lunch or something 2 weeks ago. However, you probably remember a very big life event, like your first car crash, or your wedding, or like a first date, or like maybe when your siblings were born, things like that, where you were very happy or very sad or things like that. So we can tell from this that emotion does enhance memory, and it does help learning. So part of the reason is because of this little guy right here called the amygdala. And probably some of you have heard of it, but it's this small almond-shaped red bean-type structure. And anatomically, it sits right on top of the hippocampus, which is what we were just talking about. So they are very closely linked and related. And this amygdala will basically light up whenever you have a very high emotion. So you're very happy today, your amygdala is probably more active, and it'll tell your hippocampus to mark this moment. This moment is important to me as a person. I felt really happy today, so I will consolidate this memory better. And so amygdala activation can enhance memory encoding. An example of this is my sister 8 years ago. We were on a family trip, and she tried to jump scare me when I was coming out of a public bathroom. So she waited for footsteps, and then she was like, boo, right? And then, that's not me. So she scared this like really random lady, and she remembers this so vividly. She was telling me like the other day, she was like, do you remember that this happened? I said no. But she remembers this so vividly to the point where she remembers like our parents laughing and how embarrassed she felt from traumatizing this random lady who probably still remembers this too because she was probably really traumatized as well. However, I don't remember this at all, because to me personally, I just came out of the bathroom when they told me about it. But that's not important to me or my survival, but it was important to her. So this is her own learning loop that's individual to her herself. And you guys probably each have an instance of this where you were very embarrassed, or you did something and like there were consequences that were emotional, that made you feel really sad, and maybe you won't do that again. So these are things that like your amygdala can enhance your memory. So talking about all this, how can you like take away from this and how can you improve this loop? Well, now that we know that the amygdala and the hippocampus have crosstalk, we know that emotion can strengthen learning. And another type of emotion is curiosity. Asking yourself questions can strengthen your memory, especially pre-testing. We think that we need to study so-and-so hours before we start testing ourselves. But actually, if you pre-test yourself before you even start studying, you're creating curiosity around this question, and that will actually help you encode your memory better. For example, if I ask you right now, who was the 33rd president? Any guesses? Joe Biden. Okay, very close. It's actually Truman. But now that I made your brain search for that information, and obviously you might get it wrong because you've never learned this material before, but the fact that you answered it and you forced your brain to think about it very actively, and I tell you the answer now, you're going to remember that very better than if you had just read it passively off a list of presidents, which we might have all done before, and we still don't remember. So also, this is how you guys are studying right now, most likely. Cramming before the day of the exam, for just not thinking about it until the day before, and then you forget it right after you take the exam, and then before your final exam, you have to cram like an all-nighter. But this is how you should be studying to help your memory. So you should be trying to retrieve that information every single day so that you're strengthening your memory trace and helping it consolidate over time. And this way you can take a little break before your exam and not be as stressed out and also sleep better so your memory can be better. Obviously easier said than done, but this is the final loop. In conclusion, your attention is kind of filtering all the information that comes into your brain. Your emotion can prioritize or tag certain memories over others, and that can help you encode these memories better. And therefore, your memory now will also dictate where your attention goes in the future. And this loop will run forever and ever and ever. And this is how we are learning things, and how some things we remember way clearer than other things. So to improve your grades, you should do all these things. I don't know if you'll actually do them, but I'm letting you know that you should do them. And you should also eat blueberries because they also help memory, which is a very interesting little fact. So you actually don't need a better brain, you just need to understand the brain that you have right now. It's your brain, your own personal loops. Every single loop, like everything from how I'm talking to you right now and how you might talk back to me, everything is a loop in your brain. And all of these loops have been running since you were born up until before this talk. And now I hope maybe this one loop will run a little more intentionally after this talk. Thank you.